Hello viewers, welcome to Senior College Mathematics. Topic of discussion is probability. Lesson 2, General Probability Formula. The probability of an event E, denoted by probability of E, is defined as the ratio of the number of required outcomes to the number of possible outcomes or total outcomes. In other words, probability of an event E is equal to number of required outcomes over number of possible outcomes. When E is equal to 1, if the probability of an event is 1, then it is sure or certain to occur. That event must take place. If its probability is 1, when E is equal to 0, if the probability of any event is 0, then the event is impossible. It can never occur. Therefore, the probability of an event lies between a sure event and impossible event, that is between 0 and 1. What this means is that in the study of probability, any answer you want to obtain can be 0, it can be 1, it can be in between 0 and 1. So there is no negative results in probability, and there is no result above 1. The range of solution to probability problems is a number which satisfies the inequality 0 less than equal to probability of event E less than equal to 1. The implication is that we do not have negative answers, none values greater than 1. For any event, the probability of success plus failure, that is, the event occurring and not occurring, the sum is equal to 1. That is, probability of success plus probability of failure, it is equal to 1. So let's denote success by E and failure by bar E. So the probability of failure or non-occurrence or not happening of an event is 1 minus probability of its success. So probability of failure or that event will not happen is when you subtract the probability of success of that event from 1. Next, we shall consider some examples in order to learn how to use the general formula of probability to solve problems. And we have example 9. There are 22 boys in a class and 18 girls. If a student is chosen at random, what is the probability that this student is a girl? So the interest is on a girl. Solution: probability a girl is chosen is equal to number of girls in the class, that is 18, over total number of students in the class, that is the sum of the boys and the girls, and that is 18 over 40. To write your answer in lowest form, divide the numerator and denominator by 2, and you have 9 over 20. Example 10. If today is Tuesday, what is the probability that the next day would be Wednesday? Solution. Probability the next day will be Wednesday is equal to number of Wednesday in a week over total days in a week, and that is 1 over 7. Example 11. A basket contains 9 green balls, 3 yellow balls, and 12 blue balls. Find the A part, possible outcomes. B, probability of picking a yellow ball. C, probability of picking a green ball. D, probability of picking none of the balls. Solution. For the possible outcomes, you need to note that the number of green balls in the basket are 9, yellow balls equal to 3, blue balls equal to 12. For total outcomes, that is total balls, you add all together, and that is 24. B part of the question, probability of picking a yellow ball, that is number of yellow balls over total balls in the basket, that is 3 over 24, which reduces to 1 over 8. C part, probability of picking a green ball is equal to number of green balls over total balls in the basket, and that is 9 over 24, which reduces to 3 over 9. D, probability of picking none of the balls, that is 0 over the total 24. It remains as 0. Example 12. There are 21 balls in a bag, some red and some yellow. If a ball is picked at random from the bag, the probability of picking a red ball is 2 over 3. How many yellow balls are in the bag? Solution. First, find the number of red balls since its probability is given. Once you get it, you do subtraction with the total and you get number of yellow balls. Probability red ball is equal to number of red balls over total number of balls in the bag. That is 2 over 3 equal to number of red balls over total 21. If you make number of red balls the subject, you have to cross multiply and divide both sides by 3. You have this result. That is 2 times 7 equal to 14. Therefore, number of yellow balls is equal to total number of balls 21 minus number of red balls 14, and that is 7. Example 13. In a single throw of 3 fair coins, find the probability that A, 1 head, 2 tails appear. B, 2 heads, 1 tail appear. C, at least 1 head appears. D, no head appears. Solution. We need the sample space before anything else can be done. Let the sample space be denoted by S. So if you pair the 3 fair coins, you have this possible sample space, and the number of elements in the sample space are 8. Next, we shall look at how to generate the sample space. To generate the sample space, you need to pair the first and second coin together first. So the first coin, two sides, head and tail. The second coin, two sides, head and tail. So you take the head of the second coin and pair it with the two sides of the first coin. You have head, 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 tail. You take the second side of the second coin, that is the tail, and pair it with the two sides of the first coin. You have tail, head, tail, tail. So you have the outcomes for the first and second coin. Then you take the outcomes, first and second coin, and match it with the third coin with sides, head and tail. So you have these outcomes for the first and second coin. Then this is for the third coin. You take the head of the third coin and pair it with the outcomes of the first and second coin. You have these outcomes. You take the second side of the third coin and pair it with all the outcomes from the first and second coin, and you have these outcomes. When you put all together, you have the sample space. Let's go to the A part of the question. You are asked to find the probability that one head and two tails appear. Let's use E1 to define the event that one head and two tails appear. What you do is that you go to the sample space and locate the sample points with one head and two tails. When you do that, you have this subset, and you have three elements in event E1. Therefore, probability that one head and two tails appear is equal to number of elements in one head, two tails, that is E1 over total elements in the sample space, and that is 3 over 8, and it is in simplest form. B part is two heads and one tail appear. Let us use E2 to define the event that two heads and one tail appear. So you have to extract this event E2 from the sample space by considering all the sample points with two heads and one tail. When you do that, you have this subset, and three elements are inside. Therefore, probability E2, that is two heads and one tail, is equal to number of elements in E2 over total elements in the sample space, and that is 3 over 8. C part of the question, you have at least one head appears. At least means where you have one head, where you have two heads, and where you have three heads, one and above. So let E3 define the event that at least one head appears. So you have the event E3 equal to, you go to the sample space and locate all the sample points with one head, two heads, and 3 heads, you have it in this form, and they are 7 in number. Therefore, probability E3, that is at least one head appears, is equal to number of elements in E3 over total elements in the sample space, and that is 7 over 8. D part, no head appears. Let's use E4 to define the event that no head appears. So E4 is equal to, you go to the sample space and consider all the sample points, or the sample point where there is no head. That is, you have tails or true, and you have one of its. Number of elements in that event is 1. So therefore, probability E4, that is, no head appears, is equal to number of elements in E4 over total elements in the sample space, and that is 1 over 8. Example 14. The histogram below gives the ages of students in the final class of a school. You have the histogram, you have the ages axis, number of students, which is the frequency axis. A part of the question: how many students are there in the class? B, if a student is chosen at random from the class for the post of prefect, what is the probability of choosing, Roman figure 1, a 16 years old or an 18 years old student? Roman figure 2, a student in the modal age. To answer the A part of the question, this bar is for students age 15. They are 5 in number. 16 is for 10. 17 for 20. 18 for 15. Then 19 is for 5. You add all together and you get the number of students in the class. Solution. So you have the table showing the various ages and number of students. So students that are age 15, they are 5 in number. Age 16, they are 10. Age 17, they are 20. Age 18, they are 15. Age 19, they are 5. If you add up together, you have 55 students in the class. Then B, Roman figure 1, you are asked to find the probability that a student chosen for the post of a prefect is 16 years or 18 years. As we proceed, we are going to examine addition rule of probability. That rule makes use of or. So this or implies addition. So you add probability 16 years to probability 18 years. So how many students are 16 years? They are 10 over total students 55 plus students who are 18 years, they are 15 over total students 55. So here you have like fractions. You simply add the numerator, that is 25 over 55, which reduces to 5 over 11. We have to get the modal age. The modal age is the age with the highest frequency, 20. So the modal age is 17. Now the question says probability that a student selected is in the model age. The model age is 17. How many students are 17 years? That is 20 students over total number of students 55, which reduces to 4 over 11. End of lesson 2. Thanks for following to the end. Don't forget, watch out for more from the voice of Peter Kos. If you are not safe, your life is in crisis, your life is in trouble. To avoid all of that, you have to give your life to the Lord Jesus Christ and confess him as your Lord and personal Savior every day of your life. If you are saved already, congratulations. Live righteously and be prepared, because on the last day, some will be taken and some will be led. Be good to yourself, stay out of trouble, study your books, do the needful at all times, flee every appearance of evil, don't defraud others to make money, find something good and genuine to do with your hands and your brain, and the Lord will bless you. Goodbye and stay tuned.